Hello, in this video I will be predicting the future using nothing but math. I will be essentially predicting my speed before I do something, and then seeing if it matches up with my actual speed after I do that something. So let me tell you what I'm doing. I start at the top of a hill with 0 velocity. I roll down on my bike, and then when I pass a certain fence post, I will be at a certain speed, and if that speed lines up with what I predict my speed will be, then I will have predicted the future using nothing but math. Now, first, I need to get some constants down. I need to know the mass of me plus the bike. I need to know the mass of a wheel so that I can get the rotational inertia of the wheel. And I need to know the height difference that I will be going down. So from the fence post to the top of the hill, what is the difference in the height? I will show you the equations in the next clip, but I won't be explaining them. So you can nitpick them if you want, and I will respond to them in the comments. Okay, I got a bike. It has a flat tire, it squeaks, and it doesn't fit me at all, as my old bike I gave away a while ago. So it's kind of difficult to ride, but you know, it'll work, okay? So now, all I gotta do is measure myself and the bike's mass on a scale I brought outside. Hi, so it's been 2 days since I weighed the bike because I really didn't want to have to take off this wheel and weigh it. So I was going to give up on this video, but I decided I was walking out here today and I was like, this is actually going to be pretty easy to remove. So I got a wrench and it fits, and I'm going to remove this wheel and then weigh it, because to get the mass of the wheel, I need to remove the wheel. But in order to get the rotational inertia, I need the mass. So the equation won't work unless I know the mass of just one wheel, which is why I need to take it off, and then I'll run it to the scale. So cut to future me. Okay. Now that we have the mass of the wheel, we need to get the height difference from the top of the hill to the bottom of the hill. That's the delta H. But first, we need to put the wheel back on. So, see you in a second. So, before we get the height, I'll say 2 errors that I already kind of have in my head. First, I think that obviously there's gonna be friction between the tires. This bike isn't great, not the ideal bike. So the speed will likely be over what will actually be the actual speed at the bottom of the hill. Like the predicted speed will be above what the actual speed will be, because the friction is going to take away some energy, and it's not going to all get converted into kinetic energy. Second, I assumed the wheel had most of its mass at the rim, which I guess it does, but I noticed when I took this off that there was a metal pipe in the center of the wheel, and that might kind of make the assumption wrong a little bit more. It might push it closer to a disc, so it's going to be some fraction of mr squared, the rotational inertia would be, but it should work out enough. I think the estimate will be good enough. So, we'll see. That's just the 2 errors that I think will happen. But now it's time to put on my shoes and walk up the hill, or I'll drive, or whatever. But in the next video, I will have gotten the height difference by using my altimeter app. Hi, so editing me here. I did get the height difference, and then right afterwards, I just got a video of me, like the speedometer app while I was going on the hill. So it didn't really, I didn't really even show you the height difference. It was 61 meters, if you were wondering. So there's that. Sorry I didn't show you that. The next clip will be footage of the speedometer as I go down the hill.
It's one small step for man, one giant leap for mankind.
So when it was at the fence post, it had gone back down to 16, as you saw on the speedometer. And I had predicted 41. So that was a big error. I have a few reasons why, though. And I have a few reasons that could also account for the opposite of my error. So first reason, I'll start with the opposite of my error. If my rotational inertia, if the spokes and the mass in the middle of it that kind of went out of the inner radius of the tire actually made a like non-negligible effect on the rotational inertia, then the speed should actually be higher. Like the actual speed should be higher than what I had predicted, because I had assumed that all the mass was at the edge, which it wasn't, but it was a pretty good assumption since the spokes didn't seem like a big deal, but the center piece kind of worried me, though obviously the speed wasn't higher than what I had predicted. It was quite lower. That's not, I mean, there's probably a billion other reasons, but mostly I was thinking of reasons why this could happen, why it was so much lower than expected. First, the tires were insanely deflated. So there was a lot of deformation, which means that there was a lot of energy lost. Second, friction. It's always friction. Third, the gears were rusted, so there was even more friction inside the turning of the wheels. So there's even more resistance in like the actual like the torque that needs to be supplied and everything. So that was another error. That was another thing that I didn't account for. And plus, the tires being deflated not only caused deformation, but also more surface area contact, so more chances for friction to happen. And also, the hill kind of, the shape wouldn't matter if there was no friction in this world. Unfortunately, there is. But the fact that the hill kind of like leveled out before the fence post allowed for there to be more friction than there was like gravity pulling me down. That's not proper terminology, but there was the friction had definitely lowered my speed more than gravity had given me speed. Friction decelerated me more than gravity had accelerated me, which is why my speed dropped before I hit the fence post. If there were no friction, then there wouldn't be an issue, because it would just be, it'd be pure energy stuff. You could just do, no to worry about that stuff. But the fact that I had more ground to cover without more of a slope to cover that ground with, it caused me to slow down. And also, my math could be wrong, but human error is not a thing we use in physics. Though the math that I showed you actually is different than my original math, though it ended up being the same thing, except the math that I showed you, I used a different original energy formula, so it ended up being a negative in the first, like a negative in the radical, but the negative cancels out because the delta H is negative anyway, so it works out. But yeah, a lot of ways that this could have done better. I should get thinner wheels. Actually, I should get thin wheels and hard wheels. So there's no deformation and there's not a lot of friction. And I should get a more oiled-up bike. And I should... Actually, that would probably significantly improve the results of this experiment. But, this wasn't an ideal experiment, to be honest. I think one of the coolest things about physics is that you can predict the future. That's kind of what got me into physics. But honestly, you need to have the right assumptions first. So, this is a lesson in that, I suppose. And it's okay to be wrong. I was dead wrong. So, yeah.